So in this video, let's see if the function is continuous and where it is continuous. First of all, let's have a look that we're dealing with logarithms. Let's remember the basic property of logarithms, that ln of x is valid as long as x is positive. So in our case, if we actually have to have a valid function, a valid result, we must have that x has to be positive in here. So for the first case, ln of x is going to be a continuous, is going to give us actual values if x is greater than 0. And on the other hand, when we have ln of 2 minus x, well, now we want to have the input of 2 minus x greater than 0, which means that would be x less than 2. So if this holds, then we know that the function would be continuous. But the question is, what happens at the critical point? Because at the critical point of 1, we don't know whether the function is going to be continuous or not, because we have a piecewise function, we have a different shape, and we want to know if we actually approach the same value and if we have a defined function there. So let's actually write in math what is the formula or the condition for continuity and solve it. We know that we want to have the limit as x approaches 1 from the negative side equals to the limit as x approaches 1 from the positive side, and must be equal to the function at that specific point. What is the limit when x approaches 1 from the negative side? Well, from the negative side, basically when x is less than 1, the function has the following shape, ln of 2 minus x. So let's actually solve it. And let's zoom in this a bit. Okay, so let's do it over here. The limit as x approaches 1 from the negative side is going to be equal to the limit as x approaches 1 from the negative side of ln of 2 minus x, because that's what we said. The function has the shape of ln of 2 minus x. Well, what is ln of 2 minus 1? We substitute 1 into x. That's just ln of 1, and that's equal to 0. Now let's go to the other case. What is the limit as x approaches 1 from the positive side? Well, from the positive side, we go back to our piecewise function, and we can see that if x is greater than 1, so approaching 1 from the positive side, the shape of the function is ln of x. So let's substitute that into here. We would have the limit as x approaches 1 from the positive side of ln of x, and that would equal to ln of 1, and that's just 0. Okay, so we can see so far that the limits are equal. Last step is to find out what is the value of the function now. Well, the value of the function is when x equals to 1, and we can see that when x equals to 1, by this sign over here, the shape is ln of 2 minus x. So the function of x equals to 1 is equal to ln of 2 minus 1, and that's ln of 1, and that's equal to 0. What can we conclude from here? All the limits and the function are equal, so the function is continuous. Function is continuous. And function is continuous, so we answered this part of the question. In the next videos, we're going to go through the part of differentiable.